Hello there, this is exercise 15b. We're looking again at trying to numerically integrate certain functions. You have to do this sometimes because actually on certain functions it's actually impossible to integrate them any other way. So some problems just can't be integrated. But you might still want to know what the area under the curve is, so therefore you need an alternative method, and this is one such method. Now we tend to not do ones that we can't do any other way, but nevertheless the process that we're going to show you is useful. Now before we get started, I want to remind you of the formula for the area of a trapezium. You should remember this from GCSE. You get given two numbers, A and B. These are the parallel sides, and you get given the height in between, h, and the formula is a half of a plus b times h. Remember, this is the area of the trapezium. Now notice these are, well, two of them are that way around, but this third one's a bit different. But if we just quickly work these out, area equals parallel sides of the 3 and the 6. So it's a half of, well, what is effectively 9 times by 8, and I get 36 in my head, but just doing that quickly, obviously square centimetres. The next one, if I add these two together, I get 56, and my area is a half of the 56 times by the 12 in between. I think that's 336. I'm just going to do it on my calculator. So yeah, 336 again, square centimeters. And this one, well, it's a half. What will I do this in my head? A half of, now that's the parallel side, that's the parallel side. And what we're going to do actually is all the examples we're going to see today from now on will always be turned this way round. So whereas at GCSE they're almost always drawn this way round, but what we're going to do, our parallel sides will go upwards. So it's a half of 15.5 when I add those together, times by the distance in between. So let's just do that on my calculator. 15.5, half it times by 5. I get 38.75. Yes, that's right, 38.75. All perfect, so that's no problem. So look, we have to be able to approximate the area under a curve. We can't use integration. We've already seen that one way of doing this, we saw in the last exercise, was to use rectangles. But a more accurate method is to use trapezium. So rather than having a shape that basically you split into rectangles like this, it makes sense. I mean, obviously this isn't bad actually, but you can see there's gaps. It'd be far better for that same shape to go, you know what, we're going to draw a rectangle there. We're going to draw a rectangle there. And the idea is you get smaller gaps if you use trapezia. Notice we on our calculator, when we press the menu button, we got menu 9, and menu 9 lets us do a table function dead quickly on the calculator. So this is an advantage for us. We don't have to do all the work ourselves. So first question, find the areas of 4 strips to find this integral. So I should give you a couple of pictures perhaps. It says integrate from 1 to 9. This is the function. So 1 is obviously about there, and 9 is about there. And it says do 4 strips, so it doesn't take much to work out. It goes 1, 3, 5. I think my graph is overly well laid out, but you get the idea. I split it into these 4 strips, and I attempt to draw, well, you can see it. That would be relatively close to what I want to do. Then there's another trapezium, then there's a third trapezium, and then there's a 4th trapezium. And that's what I'm going to do. I'm going to find the areas of all of them. Now obviously I need to know the heights of these points above the axis, and once I know those heights, if I know this here and I know this here, then I can work out the area of that shape. So my first job is to work out the x and y values. Well, I've worked out the x values already. It's 1, 3, 5, 7, 9, and I'm going to put this into my calculator. Remember I said type in menu 9. So if we do menu 9, I want to go 1, 3, 5, 7, 9. So I'm going to menu 9 it. And it says f of x equals, so I do 5 divided by x. And it says g of x equals, I don't care about that, so just press equals. Start range, start is 1, end at 9, and the step is 2. And you should now have some numbers on your screen. and the numbers should look roughly like that. So I've rounded my numbers to what is effectively 3 decimal places. The more accurately you do it, the better answer you get. So this then is really what my 4 trapeziums are. So this has a height of 5, because at 1 it's 5, but then it's 1.67, 667, a little bit further over. That's my first one. And then my second one starts at 1.667, and then it's 1 high. And then my third one is is 1 high, and then on the other side it's 0.714, and then it's 0.714, and then a very little 0.556. And what I've got to do is I've got to use my formula, which is, if you remember, area is a half of A plus B times by H. Now H is actually, although I called it the height, it's actually the width, it's the distance in between. And the distance in between on all of them was 2. So I should really now be in a position to work out all these 4 areas. So I want you to pause the video. I'll do the first one just briefly before you do that. This first one would be, I'm going to write it here, area 1 equals, and it would be a half, because it's always a half, A plus B, so 5 plus by the 1.667, times by the distance in between, which is 2. I said it's always 2. And actually you can quite quickly see that's 6.667. So I want you to work out what area 2 is, what area 3 is, and area 4 is. And once you've worked them out, add them together, and then you can see if you get the same as me. I'm going to pause the video now. So I got these answers. Check yours against mine. Now hopefully I've got mine right. And then when you add them together, you can see you get roughly 8, 9, 10. Looks like about 11ish. Let's see what I got when I did it. So I got 12.3. Oh, there you go. So let me just check those now. Yeah, that works. I've got 12.318 actually when I typed them in, but 12.3 to 365. So this is the method we're going to try to do. Now, the one problem with this, obviously, it takes a long time. And one thing you'll also notice is you get a lot of repetition. You've got this number occurring more than once. You've got this occurring number. In fact, the middle numbers here are all occurring twice, but the end numbers only occur once. Now, because of this, once upon a time, someone sat down and thought, well, and if I can get a rule for this, this is why we have a trapezium rule. This is the rule. It looks horrendous until you work out it's really all we just did. You'll notice the first and the last y numbers that we had just now have been used once, but all the other numbers have been used twice. Now I want to show you this in action. Just make a note of this in your book. This is useful. N, of course, is the number of strips that you have. We had 4 strips just now, so it would go y0 plus y4. And the other thing to notice, the value of h, which is we call the height, but has a simple formula. You take away the values of the interval that you're trying to integrate between. So a and b, so I do b minus a, and I divide it by the number of strips I want, n. So all those bits need to be copied into your notes. And then here is an example of that same question, but this time I'm just going to try to use the formula that I've got at the top. So if you like, in my table, x and y, well, what I would say is we just need to get our head around what the y values are. Well, we had 1, 3, 5, 7, 9. Some people write an n right at the start in their table, and they all start the n at 0, 1, 2, 3, 4. So if you like the first value, the second value, the third value, the fourth. Now, interestingly, notice that it didn't work. This is like the 0th value, the first value, the second value, the third value, the fourth value. So y0 then is the value we got on our calculator right at the beginning. And if you remember, our value on our calculator was this thing here. It's 5 and so on and so on. So this would be 5. This would be 1.667. This would be 1. This would be from memory 0.714, and this was 0.556. And so the rule basically says to work out the area, you do a half of h, which we know is 2. We've already calculated that. And we go the first one, y0, and the last one, yn. So we go 5 plus 0.556 plus 2 of all the others, and we just add those together. So we go 1.667 plus 1 plus 0.714. Close brackets. And we type those in. Again, the same trick works as last time. Half times 2 actually disappears. So really we're doing 5 plus 0.556 plus 2 times that long bracket, 1.667, plus 1 plus 0.714. And I get, when I do it, 12.3 again, 12.318 again. So to 3 sig figs, this is the same result. And this is a formula then we can use time and time again. Notice if you want a more accurate version of this trapezium rule, you just need more strips. The more strips, the more accurate. The less strips, the less accurate, as a general rule. So here's an example question. It says, use 5 strips between 0 and 1. So 0 and 1, first of all, we work out h. And we do 1 minus 0. We divide by 5. And it doesn't take long to work out 0.2. You could have done that yourself. 0.2 for each strip. Now we need our x values and our y values. And I'm going to do that in the table function. I'm going to press menu 9. And my function is 1 divided by, or over, 1 plus x squared, close bracket. Or you might have done the fraction one. And g of x I got rid of. It's starting at 0, going up to 9, no, going up to 1, sorry. And it says in 5 strips. And it works out for you straight away. And where was I doing this? I'll go back to that because I made a mess of that. 0 to 1 is step is 5, 0.2 then we worked out. So this is my table, and I've got obviously 0.2. Now actually what you realise is these x numbers aren't that important. What we care about is the y numbers. The y numbers are 1, 0.9615, 0.862, 0.7352, there's 2 more to go, 0.6097 and 0.5. So chucking it into my formula gives me area equals a half of h, which is 0.2. And then I do the first y, the last y. 1 plus 0.5 plus 2 times all those in between. That's 0.9615. You can see it's a bit of a pain typing them all in, writing them down, but relatively easy to do. Plus 0.7352 plus 0.6097. Okay, so if I just type that into my calculator, menu now, 1.5 times 0.2 times by open bracket, 1 plus 0.5 times, plus 2 times by open another bracket, 0.9615 plus 0.862 plus 0.7352 plus 0.6097. And I get an answer of 0.7837. And the answer was 0.78436, so it works perfectly well. Now here's a trapezium rule question. It says find the use a trapezium rule to do this. It says 6 strips this time. If you draw a picture of it, it looks like that. Again, I'm just going to put this into the menu. Menu 9. So I've put it in my calculator. The answer I got are those. Notice, by the way, h was pi minus 0 divided by 6, which is pi by 6, which is why every time my h value has, my x value has gone up by pi by 6. But then I chuck it into my formula, I work out my area, and it's a half of the h times by bracket, the first plus the last, that was easy enough, plus 2 times all the numbers in between. So 0.5 plus 0.866 plus 1 plus 0.8, that's an 866 plus 0.5. I've just typed it in, I got an answer of 1.95. I hope you remembered, by the way, to put this in radians on your calculator, otherwise you won't get the same answer as me. So 1.95, and that's what the answer is. A couple of things I'm going to have to do in class. Percentage errors I'll go through with you. And then I've got a couple of questions for us to have a look at. But then essentially we're doing exercise 15b. So that should make a little bit of sense, and we'll finish it off in class.